So maybe while we wait for Rodrigo to come back, I can maybe start at least presenting myself and what the module will be about. So my name is Audrey. I'm a PhD student, way up on the end of the PhD. And so within this introduction to our session, we're gonna look into data wrangling, so how to manipulate data frames mostly. So for the learning objectives, we'll work with dplyr. That's one of the most used packages within the tidyr verse. And then we'll learn how to pipe different functions with the pipe operator. That's module, arrow module, something like that. But it's really useful to squish code in a more readable way and to be able to do multiple operations one after the other. Then we'll manipulate data frames with that and learn what to do when we have missing data in our data sets. So the first function that is really useful within dplyr is select. So I printed some parts of the help page documentation of select. And so it's only to select some column or columns of a data frame. So the first argument it expects is your data frame. And then after that, you can specify columns by the name. You can also use it to select multiple columns. So one example, if we use iris, that is, I don't know if I can remove the Zoom things that are in the way, but hopefully they'll go away by themselves. And if not, I'll try to fix it. So yeah, if we have iris, that's one of the data frames that's inside R. It's one of the data sets that is native to R. It has 4 different columns. You have the sepal length and width, the petal length and width, and then the species. And there's 3 species, Setosa, versicolor, and a third one. If we want to select only the species of this data frame, you can just use select the name of your data frame, iris, and then species, no quotes. You want to use the column name as it is without quotes.
Did you type the control?
I don't know where to move my mouse to. Oh.
There you
go. Is it this
Yeah.
one? Perfect. Thank you. I don't know which way to go to change the screen. But yeah, you can also select multiple columns at once. And to do that, you just specify the column names with a comma in between, again, without quotes. And then you can also use it to rename some of your columns while selecting them. So if you want to rename sepal length to just sepal for whatever reason, you can specify it within select. So you have the name of the data frame, and then the new name that you want to give equal, and then the actual column name that you want to read. So this is for select. This is the first function. But instead of selecting columns, we can also select rows based on some conditions that they need to fill. And this is done with filter. So again, the first argument of filter will be the data frame that you want to manipulate. And then after that, you put your condition. If we want to select all rows with a specific species, in this case, then you say that you want to filter iris. You want to filter based on the species. Here, it's a column name without quote. And then you give your condition. So in this case, you want the species to be equal to versicolor. That's one of the 3 species that is available. So versicolor, because it's an argument, will be within quotes. The column name is not. And then it's a double equal because you want the logical operator equal, not the assignment operator single equal. But then you can also combine multiple conditions. If you want to select all individuals, all flowers that are of species versicolor but have a sepal length below 6, then you can put all conditions separated with the AND operator, or you can do the same with an OR operator. You can really combine all the logical operators here. To go within a slightly more complex function, you have group by. The point of group by is to split your data frame into multiple sub data frames based on values within a column, such that then you can do an operation on each of them. So in this case, if we want to group by the species, we have 3 different species within our object iris. Want to split it in 3 to later do something about it. We can group by iris species, again, name of the column, no quotes, and then it returns a tibble, so it's another object type. And it's telling you that we're grouping by the species, and then within the brackets, the square brackets is telling you how many groups it created. In our case, we have 3 species, so we have 3 groups. And then here it's showing you the result of one of those 3 groups where it's all listed as species. So you can use group by to then apply a function to the result. But if you know that you want to apply a very simple statistic to those different groups, you can use summarize from the get-go. So summarize will do group by and then apply another function. It is using either the British way to write it or the US way. You can use an S or a Z. It will understand both. So that's nice. But then it, again, always the first argument will always be your object that you want to summarize. And then you have to specify the group that you want to form, but also the function that you want to apply. So a very easy sample would be to summarize the petal length by the mean. In this case, we don't create any group. We just want one group that is everything and want to get the mean of petal length. And then we can also not only rename the different columns that we want to create, but also create multiple ones. So again, in this example, nothing is grouped. We use the full iris dataset, but we want to get the mean petal length that we rename mean underscore petal underscore length. We can get the standard deviation with the SD function and then the mean of another argument. And so we can create all of them like this. And it will create a new object, a new data frame that has all the summary statistics that we asked for with the rename names that we asked. And here it's again a single equal sign because we are not trying to do a comparison, we're not trying to do logic, we're trying to reassign the result of a function to a new name. Next function is count. It simply counts the number of individuals. There are multiple options that I won't go into because they're complicated. So I'll just show the most simple use case. Say that you want to count the number of individual of each species. You count within data frame iris, the species, and it will tell you that this data frame iris has 50 flowers of each species. But you can also give a condition. So species, it's easy, it's a factor, so it has only 3 strings that correspond to the species. But if we wanted to count the sepal length, we would have as many sepal lengths as we have individuals. So maybe we want to only count based on a specific threshold. So in this case, I chose to get the number of flowers that had a sepal length above or below 6. And this is what it tells me. It's telling me that I have 61 flowers with a sepal length above 6 and 89 that are all either equal to 6 or below. And again, I can rename columns. I can do multiple operations within the same function. I'm not limited to only one counting. I can do multiple. And in the case I do multiple counts, in the case I specify multiple columns or conditions on which I want to count, then the output will be the combination of each of them. So in this case, if I want to select on the species and the sepal length, it won't tell me the count of the sepal lengths first and then the species second. It will do all combinations and then give me the numbers for all those combinations. And then I think the last function that I found really important to manipulate data frame and that we'll go over is mutate. It's to transform columns. And what do we mean by transforming? Is that we can apply functions using a combination of columns within our data frame. So in this case, if I want to create a pedal surface, assuming that my pedal or rectangular in shape, and I can just, or triangle rather, I can multiply the length with the width and then divide it by 2. It would also work if the pedal or diamond shape. And then I want to create a new column with this value, then I can use mutate for that. So I specify on the right side of the equal sign the operation that I want to apply. And then on the left side, it's a new name. And so you can see that with that, I can create a new column that is the surface of the pedal. And then you can do different types of operation. It doesn't need to be multiplication, division. You can do sums. You can do whatever you want. A useful resource that is in the slides, in the scripts. I can also share it later on Slack if you want. There is a cheat sheet for those functions, but also more. It is just a recap of, okay, if you want to do this operation, this is the function that you need to use. And you have, here it's quite small, but if you zoom in, you have very useful schematics of how the function works, highlighting if it's the rows or the columns that are getting changed. So I highly recommend that you save this cheat sheet somewhere, at least at the beginning of the applier, to have a summary of what the function names are. So before we go into the hands-on, I will spend a lot of time on the hands-on, don't worry about it. A bit more information about the pipe operator, because it is often used in combination to all the functions that I just showed. So it was hard to show one without showing the other. So the pipe operator permits to put multiple functions one after the other and give the output of one function as input to the next. So this way we can string functions one after the other. One example is, so if we wanted to have mean stats by groups. So we want to have the mean pedal length, mean pedal width, and then same for a sepal. For each species, you can use group by to separate your 3 different species, store that into an object, and then you use summarize on that object to have your statistics for each species. That is the old way to do it without pipe. Now, if you do want to use a pipe, then you can just specify from the get-go your data, the object that you want to do operations on, then the pipe operator. Then you say, okay, so I want to group by, you want to use the function group by on that object, and I want to group by species. So you only specify now the column that you want to operate on. You skip the first argument. You don't need to specify the name of the data frame anymore. And then you pipe again because you say, I'm not done. I'm not just grouping by. I also want to summarize. And then you give your summary statistics and you get the exact same result. But now it's on technically 1 line less, but you could, in theory, put everything on the same line. And most importantly, you don't store an intermediate object that you don't really want. That group by result on the left, group by species, you don't need to keep that object. What you were interested in was the result. So if you were to save intermediate objects every single time, it would require a lot more memory. Here, because you're using the pipe, you're doing all operations at once. You only save your result if you want, and then you're using overall less memory. So again, if we take our iris object, that a reminder has 5 different columns. Oh, actually, those are just slides that go over everything that I said. So your iris is then given into group by as the first argument. It's not explicitly written, but it will be the first argument. And then again, the result of group by will be given as the first argument of summarize. Okay, then we can start with the hands-on. I think I went a lot faster than I planned on everything before. So before we go into the hands-on, are there any questions? Yes.
Why these different functions?
It's not just summarize that uses different functions. Well, what do you mean by function in this case? Do you mean an R function or?
We need
Mm-hmm.
I guess we have multiple functions.
Well, you can have functions as summarize. The goal is to get a summary statistics. So yes, you can apply a mean function to summarize, but if you wanted to have something that is more complex, something like, to have an example in mind, an operation between different columns that is not already a function in R, then it would be mutate. Like in the example where I wanted to get the area of a petal multiplying to the width and the length, then there is no function in base R that computes the area given two functions. So in this case, it's not summarize, it's mutate. But yeah, if there is a function that you want to apply on every element of your data frame, but like as a whole, because here the mean, it's not the mean per individual, right? It's the mean for the whole column. Then yes, it will be summarized. Did that answer the question? Was it clear? Or I think it will be clear on a case-by-case scenario, but yeah, overall, summarize, it's applying one function to a column. Any other question? Okay, then the first hands-on, it's a conversion exercise where you have a script that's already written that uses another data frame that's also in base R, so it's not iris anymore, it's empty cars. But so I gave you a few different statements. First, I group by some columns within the data frame. Then I add a column that it's an operation on 2 of those columns. And then I produce summary statistics. And what I'm asking you is to convert this into the piped version. And so we go from this to what is above through all those steps. Okay, then the second hands-on, a bit longer because it's a bit more complex. So now we're using the pipe operator that I'm gonna let you use at your own discretion, but also using the different functions that we just saw of dplyr. So as a hint, I put the functions on the right and with a mini summary of what they do. But what I'm asking is, so using that same empty cars object as the previous hands-on, so this one, we want to have a sum of the gears and the carburetors, and in the parentheses, I put you the name of the columns because some of them are not super evident. Then we also want to filter based on the number of cylinders and have it stratified, so grouped by engine shape, and the engine shape is the VS function. And so I'm showing you what I expect as a final result. So if you get this result at the end, you're good. Hands-on 3, it's a bit thicker because here it's not, the goal is not for you to code something, it's to find the errors. I made 2 different codes. One is an error where I think I want to have something, but I don't get it. The other is actually I get an error message. Pick one, either one on the left or one on the right. If you have the time, you can do both, but pick one and try to find the error. And then in about 10 minutes, if you wouldn't mind explaining what you found to the class, that would be great. Okay, so moving on to the next part, but I'm going to stick around during the pause if there are additional questions. And again, everything is hopefully clear online. Pivoting functions. So data frames are usually with predefined rows, predefined columns, but sometimes it doesn't really suit our needs. So we need to pivot them. What it means is that we can convert columns into row names and vice versa to have a different shape of your data. And this is done with pivot longer or pivot wider. And here it shows you an example. It's just the first few rows of, I forgot the name of the data frame, but it doesn't really matter. You have, oh, it's a billboard. So you have different artists with tracks and their position in the billboard across 8 weeks. In the screenshots. And now I want to, instead of having a different column for each week that are here, I want to pivot it such that every week now, because a new element in column week, and then the rank is what was here. So if we have for a 2-pack, the first week it was rank 87, and then second week was 82, and they're on different columns. By pivoting, and now I have them on different rows. And then you can switch from one to the other. So this is for pivoting. I'm going to come back to it in the last hands-on, but you can see that sometimes pivoting and doing operations like that can cause missing values. Like in this case, it's not due to the pivoting, sorry, there are missing values. Like 2-pack, we have the data for 7 weeks, but not the 8th. And so the missing values is represented by an NA, that means not attributed. And there can be many different reasons for those missing values. In the medical, if the data is medical, it can be a misappointment. It can be an error in measuring instruments. Depending on your data set, it can be sampling stochasticity. For 2-pack, I don't know what was the reason why it was missing data on the 8th week, but it could be that we just forgot to check where he was, or maybe he was not in the billboard, and so instead of putting a rank 0, we put not attributed. But then we can deal in different ways with those missing values. We can choose to ignore them, drop them, replace them, or impute them. And I'm going to show an example for each of them. So ignoring missing value would be to just leave them there as they are. And some functions can actually deal with missing values, but sometimes it requires an extra argument. So here I'm using a World Health Organization data frame that has information for different countries about the number of vaccines that were given. No, sorry, not vaccines, positive smears for some disease in some children. And we see that we have a lot of NAs if I compute the mean and the standard deviation. But it doesn't mean that necessarily all the elements are missing. It just means that if one element is missing, by default, mean and standard deviation will return NA. But there is a solution. There is NA.rm. That's an argument to those functions. So if I switch this to add NA.rm equals true on the mean and the standard deviation, then I compute them. So what it does is, so whenever there is an object on which I want to compute a summary statistics such as the mean, and there is an NA, by default, it will return NA. If I say NA.rm equals true, then it will just remove that NA and compute the mean on the remaining elements as if the NA did not exist. So technically, the mean and the standard deviations are computed on fewer observations, but at least you're using the observations that you have. Sometimes it's enough. Sometimes you don't want to do it. It really depends on it's a case by case scenario, because say that you had for Afghanistan, I don't know, over 80 individuals, you only have the data for 2. Do you really want to compute your mean on only 2 individuals? It might not be really relevant. So it's up to your discretion to understand when to just remove the NAs or when to keep them. You can also drop them. So it's basically what any.rm does. It removes the NAs, but temporarily, only for a function. You can also decide to completely drop your missing values manually yourself to filter out everything before applying other functions. However, drop NAs will consider all columns, and so it will drop a lot. If you have one missing data, then it can remove everything, because by default, it will drop all rows that contain one missing column on one missing value on any column. So in this case of the who, even you see that you do have some values. If you do drop any by default, it will remove everything, because here I'm not showing all columns. There are a lot more in this data frame. So be careful with that. You can do hacks to say, oh, I don't want to remove all columns. I first want to compute the columns for which there is a certain percentage of missing values. So we can try to, so first you remove the first 2 columns, the country and the year, to only have the data information. Then you test if each entry is an NA with an A, and then you count the number of sums to get the number of rows, to get the total number of entries, and then you check how many entries are not NAs, and then you can select some rules to keep, etc. There are hacks around this, but it's not trivial. By default, drop NA will drop everything, and if you don't want to drop everything and drop based on a certain percentage of occurrence, then you have to do more. But it's a solution, and then once you're done with this, you can use your data frame and you don't have to deal with it anymore. You can also choose to replace missing values. So instead of dropping them or ignoring them, you can replace them with a value that you think is relevant. So there is a function for that to replace the NAs. It's called replace NAs, but then you need to decide what to replace them with. And so in this case, I first had to create a replacing list to select where, to be able to determine, what NAs I wanted to replace. And then in this case, I decided to replace them with a 0. So first I created a replacing list. It was just 0 for each of the columns that I had in my object. So rep will reproduce 0 for how many elements I want. And in this case, I wanted as many elements as I had columns in who2. Then I just named the vector that I created with the same column names as who. But then for country and year, I did not want a 0 in case they were missing. I wanted to have a known. And then finally, I do my replacement. And so everything that was an NA now becomes a 0. But a 0 is not always a solution. A 0 sometimes can mean an NA, but not always. I also noticed that in this specific object, there were 0s before my replacement, which means that an NA should not be a 0. So again, it's up to you to decide what you want to do with your missing values, depending on what your data is and how it should be interpreted. And finally, you can impute missing values. So not give necessarily the exact same number to each missing value, but predict it based on the rest. There are different imputation methods available. I did not really go over any that is already in R because I think that the imputation method should really depend on your data set. And so if you really want to impute your data, you should find what is appropriate for it. But yeah, we can, for example, decide to impute based on a similar population in this specific example, or based on your trends. So if you have missing data for a specific year, you can go to the year before or the year after and copy paste the values, but it wouldn't always work. So the last hands-on, we theoretically only have 10 minutes, not 20, but take the time you need. And again, if you want to look at it later, everything is online. But so taking the WHO data, that's the World Health Organization data that I just showed, we want to drop the relapse columns, so any columns that start with rel, and I'm giving you the way to do this because it's complicated and it's over the scope of this class. Then we want to remove empty rows. If you feel confident, you can try to only remove rows that have at least 80% of the data missing. But again, this is advanced. And then try to pivot the data frame to change the columns and rows such that we now have country year method of sampling, sex, and age. So because here we have everything that's mixed, so SP would be the method, M is male, and then age, in this case, 0-14 means that it's a 14-year-old. Then here we also have the method SP, I forgot what it means. It's again a male, but now it's from ages 15 to 24, etc. So try to divide this into different columns. You can, if you look at the pivot documentation with the help function, it's telling you how to do this, how to split the information of one column name into different columns. Then you can do stats if you want, and maybe re-pivot the results to Y format for ease of reading. This is complex. This is hard. So I'm not expecting you to be able to do everything, and it's why I'm giving you hints. But this is a complex task. If you succeed this now or after the class, you know everything that you need to know about data wrangling. Again, this is not super basic, but it's something that I actually use very often. So I think it's important to at least mention it, even if you don't understand it 100% today, at least you know it exists. And then when you need it, you know where to look. This is also what I wanted to do with the hands-on 4. Like, again, I don't expect you to fully be able to do it today, but at least you know that it's something that's possible to do. And then you can come back to it later when you actually need to do it with your own data. The number of times that I coded my own functions because I did not Google them to try if they already existed. And so I lost so much time trying to do stuff that was there. We can go on the break.